guys, welcome to another amazing time with Mr. Moses. So today we'll be talking about relative density. So in our practical session, we'll be dealing with relative density. And what is relative density? The relative density of a substance have to do with the ratio of the density of that substance to a known substance which we use majority of the time to be water. So the relative density is the density of the substance all over the density of water. So let's proceed. In this particular session, what we'll be looking at is what relative density, just as I've said, and our aim of the practical is to determine the relative density of a solid, using balanced meter rule. So in this particular session, I will be taking us on a journey into the simple procedures for we to be able to actualize this aim. So to do this, we'll be working with some set of apparatus, and I will be taking us shortly into the different apparatus that we need to use for us to be able to actualize this aim. So guys, for this experiment, we'll be using set of apparatus, and the set of apparatus that we are going to be using to actualize our aim, we have our meter rule. Here we can see a meter rule. Apart from that, we also have knife edge or wedge, of them. Then we also have our knotted rope. This will be used to hang our masses. We have two of them. Then we have our known mass. We are using 50 grams, and for the unknown mass, this one is unknown. So for the unknown mass, we say let the unknown mass be m and let the known mass be m1. Then apart from that, for us to be, since we are talking about relative density, we will be using our beaker and filled with what? Water. The beaker is filled with what? Water. So let's move into the practical procedure properly. Okay guys, so this practical procedure is usually of two kinds, but the first thing we do is to balance this meter rule so that we'll be able to get the center of gravity, which we call G. So to balance this meter rule, I'll put it on the knife edge. Okay, now it's moving towards the left hand side, it's falling towards the left hand side, giving us a signature that the weight is towards the left hand side. So where am I to move it? I will move this meter rule towards the right. Now it is moving towards the right hand side, telling me that okay, the weight now is towards what? Is towards the right. Still not yet balanced. Okay, so my meter rule balances at, what I'm having here is that the meter rule balances at 50. So I will record this as the center of gravity G. I'll record it as 50. I'll record my G, that G is equals to 50. Okay, following our practical procedure, then the next thing we do is that we are going to place a knife edge here, just because of the practical that we are going to do. Then we will place the known mass. We are going to place, we'll use our thread, put it on one side, and also put it on the other side. Now we are going to place the unknown mass 10 centimeter away. 10 centimeter away from this end. That means from here to this point is 10 centimeter. Then my center of gravity, according to my reading here, is 50 centimeter. So I'm going to put it at the 50 centimeter mark. Then I'm going to put my unknown mass. I'm going to put my known mass on this other part. Now so while the meter wheel is at the center of gravity, I'll keep on moving the known mass, that means the 50 gram, until it balances. No, it's still not balanced. That means here the weight here is more, so I'll move it here. I'll move this backward a little, still more. That means here is more, then it's going to be in between. Yes, more. Still more, so it's in between 34 and 35 at the center. No, still more. Still more. It was the side now. It's not yet balanced. So I think this will be balanced at, let me see, 34.1. So now, just as you can see, it is balanced. So I'll record this part as my D1. I'll record here as my D1. So it's going to be from here, the distance between here and here is 50 minus 34.1. 50 minus 34.1. 50 minus 34.1, what will it give to me? That should be 15.90 for my D1. Then I will repeat the same thing again by moving this one to 20 centimeter mark. I will repeat this next method by moving this from the 10 centimeter mark to 15. It is currently at 15. Now you see here that the since I said the weight is more on this side, so what I will do is see there's more on this side. I think it's more on this side. No, still not yet balanced. So this is 36.6 for the second one, so it's going to be 50 minus 36.6. 50 minus 36.6, that will give Give me 13.40. Now we move this to 20 mark, the centimeter away. Then here's now too much, so I will take this one a little bit again. Here's much. Too much, so it's between 38 and 39. So I think here it balances at 38.7. 38.7. 1, 2, 3, 4. So it's going to be 50 minus 38.7, which is around 11.30. So then I'll move it to 25. Now here is going down, so I'll move this one a little bit. So let's see, here is still more. Move it a little bit forward to 41. Here is more, so it's going to be around I think now 87. So I got it to balance at 40.6. So from there it's going from 50 minus 40.6 is going to give us 9.40. Then lastly I'm going to put it at 30. Then at 30 is, I'll move it forward. Okay, here is much. Move it a little bit forward. Still much, so I take it backward. I think it's balanced now, so here we are, it's at 42.2. So 50 minus 42.2 will give us 7. Okay, this is 42.7. So 50 minus 42.7 will give me 7.30. So this is the first part of the practical. So we have been able to balance the meter rule by placing the known mass, by moving the known mass, and keeping the unknown mass stationary. So the second phase of the practical is just like this. Now in this second phase, we are going to place our beaker filled with water. Then we place the unknown mass inside the beaker. Then we take it back to 10 centimeter. Then we take it back to what? 10 centimeter. Then we keep on adjusting the known mass, which I told you is 50 grams. So currently now it is not balanced, so I will keep on adjusting it. Okay, keep on adjusting it. Okay, so at this point I have it to be 36.5 is balanced, so it's 36.5 away from the center of gravity. So it's going to be, we are going to record this one as D2. The first one without the water, we record it as what? As d1. But this one, we are going to record the distance from the point where it's been hanged to the center of what? Of gravity. So from this point here to this center of gravity is going to be 50 minus 36.5. 50 minus 36.5, that should give us about 13 point, that should give us 13.5. So you have 13.50. Then I will move this from 10 centimeter mark to 15. Move this from 10 centimeter mark to 15. So let me move it here. 38. So looking at it, it balances at 38.5, which is from 50. It's going to be 50 minus 38.5, which is going to give us 11.50. Then we move this to 20. Move this to 20. Then this is not fully immersed. That's what happens. So this balances at 40. So at 40 we have that this thing, it balances at what? 40. So it's going to be 50 minus 40, which is 10.00. Then we move this to 25, which is not balanced. So increase it. So we have this to be is to be 41.5, which will say 50 minus 41.5 is going to give us 8.50. And lastly, we move it to 30. And that means here is too much, so reduce it. So okay, currently what I'm seeing is that it balances at 43 points. Not yet, not fully immersed. It's at 42.5, so this will give us 7.5. So currently now we have been able to undergo the two aspects of the practical. So we balance the meter rule without placing it in water, and the second part was we did the same practical when the unknown mass was immersed in water. So the next thing we'll be talking about is we'll be going into the calculation aspect on how to be able to determine the relative density of the unknown solid. So guys, this is the table of value. If you have been able to go through the practical procedures, you are supposed to have something like this for your table of value, where your d is the distance of your unknown mass away from the end of the meter rule. Your d1 is the distance of your known mass from the center of gravity. Your d2 is the distance of your known mass from the center of gravity when the unknown mass is filled is immersed in water, and you have your d1 minus d2. So in the next practical, I will be talking about how to plot your graph and get your numeric value for the relative density of the solid using a balanced meter. Up until next time, I remain Mr. Moses, taking you guys on practical sessions. So see you guys next time. Bye for now.